Today we are going to talk about function notation, and we are also going to evaluate functions. So our essential question for the day is, what is function notation and how is it used? What is function notation and how is it used? Now the first thing that you see here is a place for us to put something about function notation. And really function notation is just a way to represent the y variable. If we were looking at it, this is function notation. And we read this as f of x. F of x. It is the same thing as the y. It's the same thing as the y equals. It's a fancy way of saying y. So, if we had a function that was y equals 3x plus 2, we could also write this as, remember the y can be replaced and we can put f of x in its place. Notice the function will not change. The only thing that changes is that the f of x is in the place of the y, because these are interchangeable. Another one might be y is equal to 4. Well, if we were to write that in function notation, then that y would be replaced with f of x. And so f of x equals 4 means the same as y equals 4. So now, as we look at the first item here, it says find the following from the graph. And so you'll see a graph and there are lots of points here. And the first thing it says is f of 6. Well, remember that the 6 is in the parentheses. And the function notation is f of x, just like this. What has been replaced? When you put the 6 here, the x has been replaced. So the question that you ask yourself is, what is the y when x is 6? What is the y when x is 6? So what we do is we come over here to the graph and we have to identify where the x is 6. Well, there aren't any points on this graph, and it might be a good idea for us to label the points so that we could physically see the number 6. So let's label these points. This would be -6, -2, -6, -2. This one, and I'm going to write it out here because you can't really see it inside the graph, -6, -2. On this one, we have -3 and 0. For this one down here at the bottom, we have 0 and -6. For this one right here, it's 1, 6. For this one, it is 2, 2. And for this one, it is 6, -3. 6, -3. So again, the question is, what is the y when x is 6? So x is equal to 6. We're going to look at all the x numbers. Those are the first numbers in the ordered pair is a 6. Thank you. Have a good day. Thank you. When the x is a 6, you'll notice right here the x is 6 and the y value for that one is going to be -3. Now we look at the next one. It says f of x is equal to 0. Now I'm going to change colors here and see if it works. F of x is equal to 0. Well, that f of x means the same thing as y. Y is equal to 0. So our question is, what is the x when y equals 0? Well, since we've already identified all the points that are on our relation, we can just simply look at the y values and find the y value that is a 6. And you'll see that there's a y value, excuse me, not that it's a 6, a y value that's 0. And so you'll see right here that the y value is 0 on this point. When the y is 0, the x is a -3. The next question is this relation a function? Remember, if we're going to be looking at the ordered pairs to determine if it's a function, what has to happen? The x's have to be different. So you could look at the x's here, and all the x's are different, so that means it is a function. The x's are different. We could also, if you didn't write down the ordered pairs, we could also just simply look at the the points that are on here and do the vertical line test. So we could say, yes, this passes the vertical line test. So all the x's are different and it passes the vertical line test. If you were going to put your vertical line on each one of these points, the vertical line would only cross the points one time. Let's look at B. Find the following from the mapping. And so again, we've got an f of x is equal to 8. Remember that f of x is the same thing as the y. So it's asking, when the y is equal to 8, what's the x? So we look here in the y column, we see an 8. The x is connected with it is a 4. So x is equal to 4. The next one says f of 3. Remember that this is f of x. And as we look at what's being replaced, the f's are the same, but here the 3 has replaced the x. So this is saying when x is 3, what is the whole y? So look at your x, that's 3, and you notice that there's a 3 for the y, and there's also a 5 for the y. So we could say 3 or 5. So we are saying, what is y equal to when x is 3? Is this relation a function, yes or no? Remember, when we look at a mapping, we only, and actually any relation for that matter, we're looking for the x's to be different. And as you're looking at the mapping, you'll notice that all of these are different. However, this arrow connects to two y's, which means that the 3 in the x has been repeated. Therefore, this is not a function because the x repeats. We have 3, 3, and we have 3, 5. The next one says, find the following from the relation. So we have ordered pairs this time. And again, we're asking the same questions. F of -2. Remember that f of -2 is the same thing as f of x. And the x has been replaced with a -2. So this is saying, what is the y when the x is -2? So we come over here to the x's. Remember, the x's are the first coordinate in the ordered pair. And you'll find that the -2 is right here. So the y that goes with that is 7. So the f of x is equal to 7 when the x is equal to -2. On this one, it says f of x is equal to -3. Well, there's no number in there, so they're saying that the y is equal to -3. What's the x? Well, all we have to do is go through and look at the y's, and we find the one that's a -3, and the x that's connected to it would be 5. So x equals 5. Is this relation a function? Nope, no function. Look at your x's, the 5 repeats. So let's just remember that in an ordered pair, it's an x and then a y. Okay? But we can also replace this y with an f of x because it means the same thing. So we can also have it look like this. So an ordered pair is an xy, but we can also say that we have x and then f of x because the y, this is a function of x. Okay? Let's continue. Letter D says, find the following from the given function. We have h of n is equal to negative 2. What is h of n? Even though it doesn't say f of x, it still means the same thing. It still means y. So it's telling us that y is equal to negative 2. And so in place of this y that's over here, we're going to be writing a negative 2. Since these are the exact same, we're going to be substituting. We'll take this whole h of n out, and we will write negative 2 equals negative 2n plus 4. Well, this looks very familiar. At the beginning of the week, we did 1- and 2-step equations. So we need to decide what's happening to the n. Well, it's being multiplied by negative 2 and added by 4. So the first thing we want to do is subtract 4 on both sides. This would give us negative 6 equals negative 2n. And then remember, when they're next to each other, that means multiply. So we're going to reverse the operation and we're going to divide by negative 2. So then we're left with n is equal to 3. So that's your answer. N is equal to 3 when y is equal to negative 2, or h of n is equal to negative 2. Now let's look at this side. This side we have h of 5. Remember, this is the same thing as h of n. Well, what's happened? The n has been replaced with a 5. So in our function, we're going to replace the n with a 5. Negative 2 times 5 plus 4. See, that's an n right there, and we're going to replace it with a 5 since n is being replaced by 5. Now, as you notice here, we have, and we can actually put the 5 here too, just saying, this is just saying when the x or the n is 5, what is the h of n? Okay? So as we're looking at it, we're just going to simplify this using our order of operations. Remember to use parentheses when you're substituting. And we have negative 2 times 5, that's multiplying. We're going to do that first. This is negative 10 plus 4. And so h of 5 is equal to negative 6. H of 5 is equal to negative 6 because the n has been replaced by the 5. So in the function, we replace the n with a 5, and we get negative 6. So on this one, we had 3 equals n, and on this one, we had h of 5 is equal to negative 6. Letter E. Find the following from the given functions. Well, on this one, it looks very similar to this one right here, where we plugged in for the n variable, except that this one has 2. There's an f, which corresponds to this function, and we have a g, which corresponds to this function. What we want to do is do them separately. So we're going to start out with f of 2, and we are going to write down 3 of 2 minus 1. Because remember, this is f of x. The x has been replaced by 2. So in this function, we're going to replace the x with a 2. Now we simplify. We're just going to write down f of 2, and then we multiply and subtract. So f of 2 is equal to 5. Well, we also have g of x. So we're going to put a g of x on here. And what has been replaced? That's right, it's a negative 1. The x has been replaced by a negative 1. So we're going to do g of negative 1, and we'll write down this function, 5 minus x. And so in place of that x, we're going to put a negative 1. Sorry about that. Negative 1. And so as we look at this, we notice that this is a subtraction problem. Remember that when we subtract a negative, that's the same thing as add the opposite, so plus a positive. You might do this as keep, change, change. So this is actually 5 plus 1, which is 6. So now, let's go back to our original problem. It was f of 2 plus g of negative 1, and it's equal to what? Well, we said that f of 2 was equal to 5, plus g of 1, negative 1, is equal to 6. Well, now we just simply add and we get 11. So 11 is f of 2 plus g of negative 1.